Okay, I've started the recording so that we can begin. And what I'm going to do now is I'm going to share my screen so that I can to go through the mock test, which is a PDF. So I need to work from Adobe. Okay. All right. So I'm just going to screen share. Share. Screen. Audio. Okay. So now you should be able to see my screen, hopefully. Yep. Okay, there we go. So now you should be able to see my screen, and I am going to go over to the question paper that we're going to go through. So I can still hear you guys. So if you want to ask any questions, you can just use your mic and ask. Otherwise, you can also type questions in the chat box. I will check back there from time to time to see if anybody's typed any questions, or I'll pop back there just to ask you if you guys are okay, or if there's anything else that you need clarified. Okay, so I want to start so that we can get as far as possible this evening with the test. So what I'm going to go through tonight is a mock test 2, which is the same learning units as your task 2. Yours is called a task 2. This is called a test 2, but it's the same thing. The only difference being that you guys are more likely to get more research type theory in your assignment or task than they give the students in these tests, which are has got a higher percentage of actual calculations. But that's one of the reasons why I wanted to use this this mock test, because it is going to allow us to have a look at some real life questions for each of the learning units. Okay, so our first question, if we go and have a look at the required, so this is one thing that I always tell when you're doing an assessment of any kind, always go and read the required first before you read the main question, because then that at least helps you to direct your thinking and you know what you're looking for in the information, instead of reading all the information and then reading the required and then going back because now you go, oh, okay, I wasn't sure whether I picked that up or not. Okay, so that just does help a little bit, gives you direction in, and also it's also, remember, you're always looking to save time so that you want to quickly find the information you need and get to where you want to be. So the first one is calculated the expected return for asset alpha, and then to calculate the standard deviation for asset alpha. So that's easy enough. So we can go back there. Let me just quickly go here. Chris, yes, I will upload this. This is a mock test, and I will upload this test with the solutions as well. Let me just put that in the chat as well. Okay. So what have we got here? We've got the manager of Cruise Investments, who specializes in investments for clients who are nearing retirement age. And I've highlighted that because that is an important piece of information that we need to bear in mind when we are answering question 1.1.3. We are analyzing whether to switch these clients' funds from their current investment in asset delta to a new asset, asset alpha. So this is the information regarding the asset alpha, which we are considering switching the clients to, but bearing in mind that our clients are nearing retirement age. They have provided you with the following information for asset alpha and have asked for our independent analysis. So first off, we must calculate the expected return for asset alpha, and then calculate the standard deviation. So one other thing that I have loaded in these documents for you guys to look at this evening is the formula sheet. So again, when you guys are doing tasks, it is just as well to have the formula sheet, print it out. It is in your more resources. Print it out and use it, because it does save you time than flipping through the textbook and looking for formulas. But more importantly, I want you to get used to using the formula sheet so that when it comes to the exams, you have already done all of your revision and all of your questions, etc., using the formula sheet. Because in the exam, you're not going to have your textbook. You're only going to have your question paper with a formula sheet attached to it. And it's essential that you are familiar and comfortable with that formula sheet by the time you sit down in the exam. So this is the way to do it. Print it out now and use it when you are doing your revision and your questions and your task too. It's critical. So if we go to the formula sheet, because also one of the most important things that you guys need to understand to work with the formula sheet now is there are certain formulas that are not on the formula sheet, and you will not be aware of that or remember that if you haven't been working with the formula sheet all along. So they have asked us for the what's the word? The expected return and the standard deviation. So on our formula sheet, we've got return on investment and we've got standard deviation. So for standard deviation, they tell us we can use this formula here, or, oh, where did that go? Or this formula over here. And when we come to doing the standard deviation calculation, I will take you through the difference between these two formulas so that you can, between these two formulas, to make sure that you can make the correct decision as to which one you are going to use. But I also just wanted to show you that this formula over here, return on investment, is not the same thing as an expected return on an asset where we have got 4 or 5 or however many different returns, possible returns with probabilities for each return given to us, or sometimes they give us 4 or 5 possible returns just for different scenarios. In other words, they'll say this one is best, this is best scenario, worst scenario, etc. Okay, so this particular formula, return on investment, is for working out our profit that we have made on an investment that we purchased. So P0 means the price that we paid for that particular asset when we bought it. And we are going to calculate as a percentage of that price, because the price is the amount of our investment, the difference between the current value of the asset, PT means the price at time today, minus the price of the asset when we bought it. So in other words, our capital appreciation plus, and CT means all of the cash flows that have been generated by that asset from the time that we bought it up until today. So usually that's something like, it could be anything. It could even be a house, a property that you bought for rental, and that you are now saying what's the current market value of the property compared to what I paid for it. So that will give me my capital appreciation on the property. And then included in that capital appreciation is the rentals that I've earned over the lifetime that I've owned the property. And that total of capital appreciation and cash flows as a percentage of what I paid for the property is then my return or profit percentage that I've made on the property. And the reason I am mentioning this is because often in tests, because students are then using the formula sheet, they go and use this formula when they are asked to calculate expected return. So you need to find the expected return in your textbook, and if it's the exam, you need to have memorized that. So the information that they've given us for the asset is they have given us 5 different economic states. So in other words, an excellent economic state, a not so good economic state, average economic state, and a poor economic state, etc., etc. Okay, so 5 different states that the economy could be in. What the return is that we expect if the economic state was each of those different states, and then most importantly, what is the probability of the economic state being 1, 2, 3, 4, or 5. Okay. So in other words, we're saying this asset alpha, the returns on the asset could be 5 different outcomes depending on the economic state, and we have been able to assign a percentage probability to each of those economic states. So we can use this information to then calculate what is kind of like a weighted average return of all of these 5 different probabilities. So first of all, over here, we have got a question mark in terms of the probability of economic state number 5. So can you guys remember what the rule is for the probabilities? What is that probability percentage going to be for economic state number 5? Chris, I don't know what that formula is that you've given me there or where you've got it from. It's best not to look them up on the internet. It's best to use your textbook, because your textbook then is going to give you the correct formula and the correct method in the examples as well that you can follow. And yes, brilliant, you're 100% correct. The probability must always add up to 100%. So yes, is it? I don't know. I didn't add up. Let's have a look and see. What have we got there? We've got 30, 65, 95. Yes. So that probability of economic state number 5 is then going to be 5%. Perfect. Okay. So now we've got all the information that we need. So for our calculation, we are going to take 15% multiplied by 20%. Plus 8% multiplied by 10%, plus minus 5%. And please note that that minus 5% must remain a minus 5% times 35%, plus 7% times 30%, plus 20% times 5%. And then we add those amounts together. So we've taken the probability multiplied by the return to get the expected return, which is a weighted return for each of the 5 probabilities. We add those together, and that then gives us our expected value, overall expected value for the asset, because we don't know which of those returns is going to be the final outcome. So this is then basically a weighted average return that we've calculated. And again, I've highlighted this one over here that it's minus 5%. Brackets means it's a negative return. And so the 5% times 35%, that must also remain negative. And when you add up this column, don't forget that you're going to say that one plus plus minus plus plus equals 515. That's also just one of those traps that the students fall into, is when they throw in a negative return or two in these expected value calculations. So you can see the expected value calculation is quite straightforward as long as you know your method and you know what to do. It's fairly straightforward, and then that will give you 5 marks. So the second part of the question then asked us to calculate the standard deviation of the standard deviation for the asset. So I said to you guys that there are 2 formulas. Oh, why has it done that to me now? There are 2 formulas for standard deviation. And this is very easy if you know what to look for, so that you know whether I'm working out standard deviation. Must I use this formula or must I use that formula? And does it matter? Yes, it does matter, if in the question they have given you a probability for each of the returns, each of the possible returns, then you are going to use this formula here that has got PJ in it, because that P stands for the probability of outcome J multiplied by the return of outcome J minus the expected return of the asset squared. So if they've given you probabilities, you must use this, because using that probability is built into the formula. This sign here means the sum of, so you're going to calculate this little formula for each of the 5 line items, and then you are going to sum the 5 answers, and then you are going to take the square root of your final answer. If in a question you were not given probabilities, and quite often, and you'll see examples in the textbook where we are not able to assign a probability to each of the possible outcomes that we have, each of the possible returns that we have estimated. In that case, where you don't have probabilities, then and only then will you use the second standard deviation formula. And I often see students muddling these two up. It does matter, and it will be incorrect if you use this formula in the question that we are looking at now, because the question we're looking at now does have probabilities in it. Okay, so this one and only this one is the one that we are going to be using. So again, we're going to have a line item for each of our economic states. We're going to state the probability that we had. Let's see if I can fit them both on the page at the same time. We're going to have the same probability and the same actual return there. And now this expected return that we calculated over here, we put in this column over here. Okay, remember our formula says the return of each economic state minus the expected return. So we have got the return of the expected state minus the expected return, and we square that. So this minus this, answer squared, and we write that here. Okay, sometimes they have an extra column. This minus this, answer squared, and then multiplied by 0.2, multiplied by the probability. And that gives us, so this is our formula, the probability, remember the formula said PJ, multiplied by the actual return minus the expected return squared. So it's just this minus sign that we square. It's not the whole, you don't multiply this whole thing out and then square the answer. It's 15 minus 5.15 squared multiplied by 0.2. So here is, we repeat that calculation for each of the 5 lines, and then we sum those 5 totals, and then we take the square root of the sum of those 5 calculations. And your standard deviation is then that square root answer. The square root of 68.33 is 8.27. So the standard deviation for this asset is 8.27%. And if you've read through the text, which I hopefully you have by this time, you will remember that standard deviation measures the amount of risk. It's an indication of the amount of risk attached to this specific asset alpha. And obviously, the larger the standard deviation, the greater the risk will be. And this deviation that we have measured, or the risk that we have measured, is the risk that our actual returns, or that our expected return, will not be close to what the actual return ends up being. So in other words, we're going to purchase asset alpha, hoping for these specific returns here if the economic states are accordingly. And then using these probabilities and the variation in these actual returns, we have measured that there's, how can I word it? There's an 8.27% possibility that the answers, the actual final answers will deviate from what we expect them to be. So the larger the standard deviation, the greater the risk that we perceive. So then for 4 marks, they then say calculate the coefficient of variation for asset alpha. So let's first just go and look at that calculation, also on the formula sheet. So they've grouped the formulas together. So here's standard deviation, and we usually follow the standard deviation calculation by the coefficient of variation calculation. So the coefficient of variation is then theta over RE, and this little theta sign at the top is here. It's your answer to the standard deviation. So you need to work out the standard deviation first to get this answer, and then coefficient of variation is the standard deviation answer divided by the expected return. So here's our expected return RE. Here is our standard deviation theta. So our coefficient of variation is the standard deviation 8.27 divided by the expected return. So remember I said that 8.27, the standard deviation, is the quantity of risk perceived in the asset, and the 5.15 is our expected return. So we are expecting an average return of 5.15% if we purchase asset alpha. So the answer of 1.61 means that for each percentage return that we expect to get, there is attached to that 1.61 units of risk, because we have taken the 8.27 units of risk and we have divided them over the 5.15 units of return. So to each unit of return or percentage of return, there is 1.61 units of risk attached to that. So this is very helpful when we are comparing lots of different assets to each other. We calculate the coefficient of variation, and then we can compare their coefficients of variation, which will help us to make our decision. Um, 15 minus 5.15, are you still on the standard deviation? And then you square it. 15 minus 5.5 squared. So your answer, I'm not going to put the percentages there just to save time. 0.15. Where is that? Squared. And then you multiply that answer by whatever your probability is. You just always follow, you guys remember from school your BODMAS. I think they call it something different these days. Follow those rules. What do you calculate first? You always calculate brackets first. So the 15 minus 5.15 squared is in brackets. So you do that first, and then you multiply the answer by the probability. So in our question here, they said calculate the coefficient of variation. Okay, so we've done that. And then advise as to whether they should switch their client's investment to this new fund, or should they keep their client's funds invested in the current fund, their asset delta. Now they are telling us asset delta has got an expected return of 4.5%. but a coefficient of variation of 0.45%. So remember what we've just calculated now for this asset alpha that we are considering. Asset alpha has got an expected return of 5.15%, but it's got a coefficient of variation of 1.61. as compared to 4.5% and 0.45. So you've got to advise whether they should or shouldn't switch, and then obviously give reasons for your decision based on comparing our results for alpha to the results that they've given us for delta. Okay, you want to think about that for a second. So this is kind of what you should have come up with. So even though asset alpha has got a higher expected return of 5.15 compared to the 4.5 of asset delta, so in terms of return, it's higher. But this is important. It's got a higher risk profile because it's got a per unit risk of 1.61 versus only 0.45 units of risk for each percentage return for asset delta. So therefore, this asset alpha is definitely of a higher risk than asset delta. And remember, I said to you we highlighted the fact that the clients considering the swap are nearing retirement age. So because these clients are near retirement age, this means that they would want to be risk averse, not to take on risk and risk their retirement savings on a risky investment at this stage of the game. So their emphasis is on preserving their capital, and they would be more risk adverse, and therefore cruise investments should advise them to stick with asset delta and not to swap to asset alpha. Okay, does that make sense to you? You understand the reasoning behind what our decision there. It is important that you guys can make those kind of explanations. So when they always ask you in a question to give a decision or what would you advise, that is the kind of format, the way that you should approach that kind of question. You always have to give the decision supported by your calculations and then provide reasons why you've made that decision. And remember, guys, always just use your own intuition, interpret it in your own way. And as long as whatever you've interpreted makes sense, then I can give you the marks for it. Because sometimes these decisions are not cut and dried. And if you've proved why you would take a certain decision or recommend a certain course of action, then I can give you the marks for that. So don't sit there and worry and think, oh, I'm going to get this wrong, I'm not going to make the right decision. You just have a look, formulate your own strategy and explain why you would have gone that way. Okay. Any questions with that particular one? It's quite a nice question to practice this Learning Unit 3, different Learning Unit 3 sections on it. Okay, awesome. So let's go and have a look at our next one. Question, oh, we've got another one, I forgot. Question 1.2. So here we've got cruise investments. So also just the marks I want to just bring your attention to. Expected return is 5 marks, which means that in an exam situation, that should take you no longer than 5 minutes. Standard deviation, 7 marks. Time-wise, you should be able to complete that in 7 minutes. And then the coefficient of variation with your decision, you've got 4 marks for that. So that's 4 minutes. So we've got 11, we've got 16 marks for that particular section of the paper. And then question 1.2, we have now got 9 marks for. And if we go and look at the required, they want us to calculate the cost of equity using the capital asset pricing model. And then secondly, with reference to our answer in 1.2.1, we must then use the dividend growth model to advise cruise investments whether they should go ahead and purchase the shares. Okay, so here we are considering purchasing shares in Neptune Limited, and we're also doing various calculations to decide should we purchase the shares or not. And if the shares are, okay, should we purchase them or not if the shares of Neptune Limited are currently Their market price currently is 50 Rand on the JSE. Round all calculations to 2 decimal places. This is important, and I'm assuming over here that they were also referring to here. Oh yeah, here they did say round to 2 decimal places. Always pay attention to the instructions regarding rounding or any other instructions. Very, very important. You can lose marks if you don't follow instructions. Okay, so they've asked us to do 2 things here. Calculate the cost of equity using the CAPM model and then using the dividend growth model to calculate the price of the shares using the dividend growth model and then decide whether we should accept the investment or not. So we're first going to go and check on our formula sheet to see, is the CAPM formula there and is the dividend growth model formula there, so that we know, do I have to memorize the CAPM and the dividend growth formulas, or will they be on that formula sheet when I come to the exam? So we are going to go down. So this is page 2. So there is the CAPM formula. So yay, they've given it to us. And here is the dividend growth model formula. They've given that to us as well. Take note with the dividend growth model formula, there are also 2 versions of the dividend growth model. This first one, if you remember from your textbook, is the, what's the terminology for it? It's where there is a stable, or what's the word I'm looking for? Not where we can use the word stable. In other words, the growth rate is going to be stable for the foreseeable future and not change. And then the variable growth model is where the growth in the dividends is expected to be a certain level initially, and thereafter it will change and then remain stable. So again, depending on what information you've been given, you will either use this dividend growth model or this one over here, the stable dividend growth model or the variable dividend growth model. Take note also that on the formula sheet, you are given the formulas, but nowhere do they give you keys to the formula. So they don't tell you what does D1 represent, or K or G or PO, what is RJ, RFB, what is all that. They don't tell you. So you have to know your formulas so that you know what each of these variables represents, so that you can use your formula and then make the correct substitutions from whatever's given you in the question into the correct places in the formula. Because obviously you're going to be lost if you don't know. It's useless giving you the formula if you don't know what each of these variables represents. So let's have a look at what information they have given us for cruise investments. Sorry, Neptune. Yes, Neptune, it's Neptune Limited we want to buy. So we've determined Neptune Limited has got a beta coefficient of 2.5 times the market beta. So again, you have to know as a student what is the market beta so that you can multiply that by 2.5 to arrive at the beta for Neptune. The market risk premium is 2%. The risk-free rate is 5%. Then in addition, they've given us the dividend history for the last 4 years for the Neptune Limited. And it is expected that the dividends will grow at the same constant rate as this growth rate in the future. So that's telling us that we must use the constant or stable, growth rate formula. 3 marks, so that means in 3 minutes, we've got to calculate the cost of equity using the CAPM model. I have typed in here the formula just so that we can see it. CAPM is equal to RF, which is the risk-free rate, plus the beta of the asset that we are considering multiplied by RM, which is the market's current rate minus the risk-free rate. So in our question, they gave us the risk-free rate and they gave us the beta, but they did not give us the current market rate. What they gave us was the risk premium. So remember, and this is in your textbooks in this section, that RM minus RF, in other words, the current market rate minus the risk-free rate, that difference is the risk premium. So the risk premium is what percentage have we added to the required rate of return, to the risk-free rate, what percentage have we added to the risk-free rate in order to compensate ourselves as investors for the perceived risk in the market. In other words, the market's overall risk compared to the risk. So risk-free rate, remember, is always only going to be associated with government bonds. The rest of the market, there is always some kind of systematic risk as well as unsystematic risk included. So that means that RF will always be more than the basic risk-free rate because of that risk premium. So in our question, they just said the risk premium is 2%. So what they've done there is they have taken RM minus RF equals 2%. And you need to know that, again, otherwise you're going to be lost. You're going to say, what must I do with this 2%? I'm looking for an RM and an RF, and they've given me 2%. So here's our RF, risk-free rate. Here is our beta, 2.5. What is the market beta? Do you guys, who remembers, what is the market beta? The market beta is always one amount. And what is that? What is the market beta considered to be? It's like a benchmark. What is that market beta, that benchmark market beta? You can remember. Anybody? The market beta is 1. So our question said Neptune Limited's beta is 2.5 times the market beta. So 2.5 times 1, the beta for Neptune is 2.5. So we can go. So here we've got, and remember CAPM stands for the Capital Asset Pricing Model. And it's very important that you remember, and it tells you this in the textbook, in this write-up about CAPM. It's right at the end of, I think it's actually at the end of your chapter number, where is it? Chapter number 3. That CAPM, Capital Asset Pricing Model, that percentage is equal to the required rate of return of the investor given the, call it the specific risk of the asset being considered. So quite often in various questions, you will need to work out what the required rate of return of the investor is. And often they will then give you the information for the CAPM model, and then you can then use the capital asset pricing model formula to work out what the required rate of return of the investor is, which is what we're doing now in this question. So RF 5% risk-free rate of return plus the beta of Neptune, which is 2.5%, multiplied by RM minus RF. And that equals 10%. So the required rate of return of an investor purchasing shares in Neptune Limited should be 10% to compensate them for the specific risk linked to Neptune, which is indicated by their 2.5% beta, as well as the market risk premium, which is currently 2%. So any investor will want a return of 10%. Then with reference to our 10% required rate of return we've calculated there, use the dividend growth model to advise crews whether they should purchase these shares or not, bearing in mind that the current market price of Neptune on the JSE is 50 Rand. So we're going to use the dividend growth model to calculate a theoretical value for the shares of Neptune Limited, given this information that we've got here regarding the dividend history of the share, as well as the required rate of return of the investor. So our dividend growth model for constant growth is PO, and remember PO is the price of one share, the price at time zero. So P stands for price, and that little zero stands for today, current. The price today of the share is equal to D1. D stands for dividend, and the 1 means the next dividend. In other words, the next time we pay a dividend, what will that dividend value be? Divided by K, and K is required rate of return of the investor, minus G, and G is the growth percentage of the dividends in this asset that we are considering. Okay. So let's go and have a look at what that answer would look like. Chris says it's 5 plus. So remember your brackets, Chris. Let me just go back and have a look. I can't remember exactly what the values were. So 5 is the RF. So it's RF 5 plus, and then beta multiplied by the 2.5. So 2.5 times 2%, that's bracketed. And we add 5% to this answer. So we take 2.5 times 2%, and that gets added to 5%. So 2.5 times 2 is 5, and we're adding that to 5. That's how we got our 10. Okay, so dividend growth model. Here I've put the formula again. PO is equal to D1 over K minus G. And we want to calculate PO. In other words, we want to calculate what is the theoretical price of one share in Neptune today, given the growth rate of the growth rate of their dividends in the past, and given the fact that we want a required rate of return of 10%. So they gave us, I'm going to just have to quickly go back here. They gave us the dividend history for the last 4 years. So we can see how the dividend payout has grown. R3.80, R3.95, 4.02, and then 4.15. So the last dividend that was paid, D at time 0, is R4.15. This would be D minus 1, D minus 2, D minus 3. Remember, in our formula, we have to use D1, which would be what is the likely dividend that will be paid out in 2020. So 2020 will be D1. So we've got to calculate what is the value of the dividend that will be paid out in 2020, given the fact that this is the way that the dividends have been growing over the last 4 years, and they told us that they are expected to grow at the same constant rate into the future. So there is in your time value of money chapter, there is a calculation there that they've given you that you can, like a maths one, if you want to call it that, where you can calculate the growth rate with this information here. But in this particular memo, we have used our formula sheet. Not formula sheet, we've used our financial calculator. So this calculation here in this table is to calculate the growth rate G that we need here in our formula. So we take the oldest dividend, R3.80, and we call that the present value because that was way back in the past. And the latest dividend, R4.15, is the future. So in other words, we've gone from the past to the future, R3.80 and R3.95, etc., up until R4.15. N is 3, and we are going to comp I. And the reason that N is 3 is because N is the not the number of years, but it is the number of growth. What's the word? The number of, don't want to say the number of growths. That sounds a bit, let me do this. Number of times the dividends have grown. So again, if we go back over here to our table, the dividends grew from 2016 to 2017, that's once, 2017 to 2018 is twice, and 2018 to 2019 is 3 times. So although we've got 4 years history, this is 3 growth periods. Okay, 380 to 395, 1, 395 to 402, 2, 402 to 415, the 3rd time the dividends grew. So that's why N is 3 and not 4. So don't forget, always whenever you enter a present value into your financial calculator, you must enter it as a negative using that plus or minus button on your financial calculator. That little button that looks like that. And then comp I 2.98. So we've calculated here that the growth rate is 2.98. So now we can calculate D1. We take D0, which is 415, the last dividend that was paid out, and we now grow it by 2.98% to calculate what the dividend will be, estimated dividend will be the next time a dividend is paid out, D1, divided by over K, which is required rate of return. We've calculated that here, CAPM, 10%, minus G, and there's G, 2.98. So maths, and we get an answer of 60.88, 60 Rand and 88 cents. So that tells us that currently the theoretical value of 1 share in Neptune Limited is 60 Rand and 88 cents. Remember, they asked us to then make a decision as to whether we recommend that they should buy the share or not, and that the share is currently trading on the JSE at 50 Rand. So your answer is yes, definitely go ahead and purchase the share, because if it's selling currently for 50 Rand, it's undervalued, and that 50 Rand is a bargain because the share is actually worth 60 Rand and 88 cents. So that's the logic that you should use to explain why you said, yes, go ahead and purchase the share. So that's also a really nice question for practicing several different aspects of the work that we've already done. Just quickly, I just want to see, we don't have much time left. So just quickly, 2.1 of question 2 is a quick one. Quickie, calculate the real interest using Fisher's formula if the nominal rate of interest is expected to be 16.5%. and inflation is expected to be 1/3 of the nominal rate. So when they specify that you must use Fisher's formula, this is in Learning Unit 3, where they've got that discussion on interest rates, etc. You have to use Fisher's formula, and here's Fisher's formula here. There's 2 versions in the textbook. You can use either one. The important thing is that Fisher's formula is not on the formula sheet. Okay. You must memorize it. So, and take a look as well. They asked us to calculate the real rate of interest. So if we look at the formula, it's 1 plus I, and I represents the nominal rate, equals 1 plus R. R is the real rate, multiplied by 1 plus H, and H represents inflation. So they've asked us to calculate the real rate. So in other words, we have to solve for R in this formula. They've given us the nominal rate I. They've told us how to calculate the value for H, which is inflation, 1/3 of the 16.5%. And we've got to calculate R, the real rate. So that also, they just make it a little bit tricky from a maths point of view to do that. But number one, you have to be able to remember the formula and write it down. And then number two, do the correct substitutions. So we can see here we've got 1 plus R, that's the, 1 plus I, that's the nominal rate given to us, equals 1 plus R multiplied by 1 plus H. And have a look at the marks. The whole this question is worth 4 marks. There's already 3 marks just for getting your formula correct and for doing the correct substitutions. That's already 3 marks. And there's only 1 method mark for then doing the maths to work out that using algebra, that R is equal to 10.43%. Okay, so this is also an important question, and why I wanted to include it, because I'm making the point that you have to memorize Fisher's formula. And obviously, guys, when I'm talking about these memorization things and the formula sheet, I'm already coaching you guys for the exam, because that is only going to be starting in about 4 weeks after task 2. So you've got to start thinking about it right now. All your revision and all your prep that you do now is aimed at making sure that you are assessment ready for a sit-down closed book exam. So my focus when I'm talking to you guys, talking through questions, etc., is always on that. I'm not worried about the tasks. You guys have got open book, and it's easy to coach you through that. Okay, so I think I'm going to have to end up there. Otherwise, we're going to go over time, and some of you might have to go on to another class at 7. Guys, any other questions? Anybody else got any other questions at this stage? Hopefully these going through this section and just the way I've taken you through these questions and talking about the formula sheet and the formulas and how you must answer questions, that all of this has been helpful and is helping you to start getting your minds into the right, refreshing memory. And guys, don't forget, it is important. You are expected to know what's in that textbook. Just listening to these couple of hour sessions that we have online is only a fraction of the time that you should be spending on the module. You need to spend hours and hours of quality time with your textbook to make sure that you're prepared properly. Okay, guys, I will switch off the recording quickly.